Hello everyone, welcome to module 8 lecture 30 and today we will discuss about remote sensing for landslide studies, right. So as other lectures, this lecture is also divided into two parts. So this is the first part. So before we continue and before we see the actual application of remote sensing in landslide studies, let us understand the potential of remote sensing. So the first advantage of remote sensing, or let's say geospatial technology, is the large aerial coverage, which is not possible with the field investigation. So when you go for the field investigation, what happens? We collect the point information or we collect the sample, so that will be dedicated to that particular location. So whatever information you extract using the conventional method or different advanced techniques, that will be dedicated to that particular location. When we talk about remote sensing, when we analyze the different data sets captured in different wavelength regions, what happens? We are extracting the information utilizing the different wavelength ranges. So that advantage we will have with respect to large aerial coverage. Next is non-destructive data collection. So here when we say non-destructive, basically non-destructive is we are not disturbing the sample, we are not changing the form of the sample. But if you remember, if you go for XRD, XRF, ICP, any other conventional or geochemical analysis or geotechnical investigation, we are disturbing the natural form of the sample. We collect the sample, we try to make it fodder or maybe liquid depending upon the instrument. So depending upon the instrument, we will be preparing our sample and that will be destructive in nature. But when we talk about the remote sensing, it is non-destructive. That means we are simply acquiring the information in different wavelength regions. Now the next one is the high spatial, spectral and temporal images. So spatial is what is the size of your pixel. One pixel is representing 30 by 30 meter of the ground, or maybe 1 meter by 1 meter, or maybe few centimeter by few centimeter. Higher the spatial resolution, you will have more information about the target. Right? With the advancement in the technology, we have now high spatial resolution. So not only in the panchromatic images, but also in the multispectral domain, we have high spatial resolution. Now comes the spectral resolution. So this spectral resolution provides you the characteristic absorption feature information about the target. Whether a particular target is X, Y or Z, that is identified using the characteristic absorption feature that is given by that particular target in different wavelength regions. Then we have temporal images. So we have subsequent acquisition of the images, or we have temporal images captured in different time frame, or the temporal images are basically the images captured for the same area by the same satellite, maybe after 10 days or 15 days interval, and that will be utilized to see the changes on the ground. So when we talk about the natural hazard, especially let's talk about the landslide, these temporal images will try to provide you information about the pre-landslide condition and the post-landslide condition. So these spatial, spectral and temporal resolutions are very useful in natural hazard studies. Now comes the access to inaccessible areas, because some of the areas we all know it is restricted and we try to visit, but because of some limitation we may not visit that particular area and we will not be able to do any analysis. But when we have remotely sensed images, that provides you the opportunity to investigate the inaccessible area from the space. So that is the advantage. Real time or near real time data. So as we discussed that for the natural hazard pre and post event, those images are very useful. So, this real time simultaneously there are measurements which are happening by different satellites that you can utilize for pre and post event information. Wide range of data, that means we are utilizing different wavelength regions starting from visible to infrared to microwave, right. So, all these informations can give you different information about the target, and those different wavelengths can talk about different properties of the same material. So, depending upon the application, we try to utilize the different domains of wavelength in our remote sensing. This is the systematic and repetitive data collection. If you remember, I talked about the Landsat data series. So, we have different sensor or satellites launched from 1979, and then till date we are having different measurements by different series of Landsat data, right. So, here you can utilize this systematic data acquisition so that you can superimpose or you can use an algorithm to see the changes. So, the pre and post event information, or if you want to see how a area has evolved over the time in a decade or 2 decades, that can be done with remote sensing data set. So, this is the brief introduction about the advantages of remote sensing or geospatial technology. Now, we will move forward for remote sensing for landslide studies. So, here there are 3 different categories. The first one is landslide inventory mapping, that is your detection. If you remember, when landslide occurs, the pre and post information is very crucial. So, when we want to do any analysis, first thing is to detect the landslide. Now, the next one is the landslide susceptibility mapping. Now, the next one is landslide susceptibility mapping, and then comes the landslide deformation monitoring. So, we will discuss all these in today's lecture, and we will see one by one potential of remote sensing application in landslide studies. So, starting from detection to susceptibility to deformation, and we will try to see different examples, and we will be referring some of the standard publication. So, here you can see the key remote sensing data sources for landslides. So, the first one starting from optical imagery, Landsat, Sentinel, Google Earth, right. Then application is landslide inventory mapping, land cover analysis, that is very crucial. Then comes the SAR or radar, synthetic aperture radar. So, here you have Sentinel-1, ALOS pulsar, and that is being used for ground deformation detection and monitoring. Then comes the LIDAR. Here the airborne and UAV based LIDARs that is available. So, here you can go for the high resolution terrain modeling. That is important when you are going for the very small scale landslide where you need very minute detail about the topography. So, the digital elevation model available in public domain of 30 meter or 20 meter resolution, that if it is not useful, then you have to go for the LIDAR. Then comes the rainfall data. Here TRMM, GPM, these rainfall induced landslide assessments are very important, because sometimes the in situ information is not available. So, in such condition, the rainfall data from TRMM or GPM, that will help you to analyze the area. This particular slide provides you the comprehensive understanding about the remote sensing application in landslide studies. So, let us go one by one. So, here you can see this is the space investigation. Here you have satellites, and here you can monitor a particular area, how parameters are changing, right. Then comes the air investigation, that is the airborne survey, and here you have UAV, space aircrafts, those will be used to generate the high spatial resolution data set. Then we have the ground investigation. So, we have laser scanner or the GBSAR. GBSAR is basically ground based synthetic aperture radar. So, this is very useful in identifying the minute changes or deformation in the study area. Then let us see here, when we have satellite, this is having a fixed orbit. So, it is having a temporal measurement. So, maybe today at 10 am, after 14 days again 10 am, then again after 14 days 10 am. So, this information will help you how the area is changing, how the topography is changing, right. And when you are having the aircraft or UAVs, for a particular area, you can fly these instruments in different wavelengths and then you can capture the information about the landslide. So, here the example of active landslide, here it is a fresh landslide, this is the ancient one, right. So, when you are having this, you can use the laser scanner here or maybe the GBSAR, and then you can see the surface deformation, and that will be of very high accuracy. Now, here in this side we have the time scale, then we have active landslide, fresh landslide and the ancient landslide. Here they have used optical INSAR, then optical data, right. Here you have LIDAR. So, this you can see and you can understand how remote sensing of different wavelength regions data is used in landslide studies. Now, this particular slide, it says the various optical, radar and thematic data used in landslide studies, particularly in Europe. So, the first one is the optical data. The blue color represents the detection and mapping, and red color represents the monitoring. The blue color is detection and mapping. So, this is the highest one, right. Then comes the monitoring, and here you can see the visual interpretation, then photogrammetry, then change detection, image processing, object oriented analysis, classification, spectral indices. How they are used in different detection and mapping and the monitoring. So, here you see in visual interpretation, detection and mapping is high, whereas this monitoring is low, right. So, similarly you can see this particular graph and you can understand how optical remote sensing or how optical techniques are used in landslide studies. Then comes the radar techniques. So, here again the blue is the detection and mapping and red is the monitoring. So, here you can see the ADINSAR, DINSAR, SAR, GBINSAR, how they are used, because these all are space based, right, but here this is the ground based. So, this ground based are the instruments are costly. So, that could be a reason that very few people are using it, but this is also having the potential in landslide studies. Now comes the thematic map. So, here you can see the percentage is in y axis and in x axis you have DTM and derived maps, landslide inventory map, geological maps, geomorphological map, hazard map, lithological map, risk map, hydrogeological map, land use map, damage survey data set and hydrologic maps. How remote sensing is used in different landslide studies, and here the detection and monitoring, they are having this blue and red color. So, this will provide you concise information about the remote sensing data sets used in landslide studies, particularly in Europe. This particular graph will provide you the information of number of landslide studies that used remote sensing data set. So, the first one is the susceptibility mapping, that how a area is susceptible to failure. So, this is highest, then the detection, then you have assessment, then monitoring, then extraction, then inventory, stability, influenced of train data, then management. So, here you can see the number of landslides. So, this susceptibility mapping where people have used the remote sensing maximum. I will try to summarize once again the advantages of remote sensing so that you will have better understanding and you will be able to perceive how remote sensing can be used in your studies, right. So, the large scale coverage, it captures data over vast and remote areas including inaccessible terrain, right. Then high resolution data where we have optical, LIDAR and SAR based measurement, and it provides you fine scale spatial resolution allowing precise mapping of landslide prone areas. Then comes the multi-temporal data. So, as I discussed before that multi-temporal data sets are the data sets captured at a particular frequency, right. So, provides historical and real time data for detecting changes over time. Then high resolution topographic data, the LIDAR and stereo satellite images generate high resolution digital elevation models to identify terrain features that contribute to landslide. Stereo satellite images are basically the images captured by the same satellite from two different positions, right. So, this is the distance between these two and they are capturing the same area. It is like our eyes. Our both eyes are placed at a particular distance, right, and because of that only we are able to generate the stereo images, and because of that we are able to perceive the height and depth information. Similarly, when you are having the stereo satellite images captured from two different positions, right. So, we will be able to generate high resolution digital elevation model, and the digital elevation models are basically your x, y, z values. X is your latitude, y is your longitude and z is your elevation. So, that information will be used further for slope and aspect calculation. This is a non-invasive and cost-effective method. Then integration with GIS and machine learning. This is the best part of remote sensing and GIS, that these images whatever we are generating through remote sensing satellites, so that can be part of our decision support system or our analysis. So, any machine learning methods can be used here to analyze our remote sensing images. Detection of ground deformation, interferometric SAR, that INSAR, I hope you remember, I discussed this in the remote sensing component, detects millimeter level scale ground deformation, right, and that can be used for the early warning system. So, what happens in the interferometric SAR? We are generating the interferograms and then we are generating the phase information, and those phase information will be used for identifying the changes, and that will be in the millimeter scale. Rapid disaster response quickly accesses post landslide damage using optical and SAR imagery. So, because it is very difficult to reach the area if there is a major landslide. So, in such condition the satellite provides you the additional eye that will be looking at the area, and that will provide you the actual scenario after the disaster, right. Satellite based rainfall data for landslide assessment, because many times many of the regions they do not have the ground based precipitation information, right. Satellite based rainfall data for landslide assessment. So, it provides spatially continuous rainfall estimates over large area and remote areas. This is very useful when you do not have the ground measurement. So many of the areas we do not have the ground station for the precipitation measurement. So in such condition, this satellite based rainfall data that will provide you the information and that will help you to do your analysis, and you can perform the landslide susceptibility or landslide studies. So let us talk about the landslide inventory mapping. So that is basically your detection. Collection of data and information on the occurrence, spatial distribution and intensity of landslide, along with the identification of elements impacted by the deformation process. So this is very useful. So the first one is the conventional method. How do we do? Geomorphological survey, then visual analysis of aerial image or orthophotos. Orthophotos are basically the satellite images where geometric correction has been done. So this is geometrically and topographically corrected data sets. Then comes the recent method. So now what we are doing? We are still using visual analysis of optical remote sensing data, but now we are also incorporating the multispectral, hyperspectral and synthetic aperture radar based data sets, right? So these will help you and these will provide you the information about the landslide. So that's how we are generating the landslide inventory. That is very useful, because when you go for the machine learning or any advanced techniques to monitor or to forecast the landslide, you also need the historical information, and those historical information can be identified or can be collected by remote sensing data set. Here this particular slide says remote sensing techniques developed for landslide investigation with time. Now here you see in 2009-2010 we had the aerial imagery, then high resolution satellite data, then laser survey, then airborne imagery, then high resolution satellite data. Here you see the years, right? Aerial laser scanner, terrestrial laser scanning, then high resolution satellite data, then spaceborne INSAR. So here these are used for the manual interpretation. This is for automated or semi-automated. This is again semi-automated. This is the 3D acquisition, then you have radar based, and when you are combining these, you are having geomorphology based feature extraction and visual analysis, and here you are going for the stereoscopic, and then we have the INSAR or radar based, that is SAR, synthetic aperture radar. So this will provide you the concise information. I am just trying to give you the flavors of remote sensing, how different remote sensing techniques can be used in landslide studies. Let us start with photogrammetry and satellite based. So this can be used for visual analysis. When we have lidar point clouds, we can go for the object oriented analysis, and then we have the SAR, we can go for the change detection, and all of these can be integrated together in GIS environment, and then we can go for the pixel based classification, and then we can also go for the object based classification, and both will provide you the opportunity to identify the pre and post conditions of the area. And then together, when you are integrating all these data sets, all these information derived from remote sensing data, then we can call it landslide mapping with remote sensing. When we talk about the visual interpretation of remote sensing data, so here the data sources will be the aerial photograph, the airborne survey that will provide you the airborne data sets, and then you have high resolution satellite images, because when you are going with the visual analysis, you need the high spatial resolution, then only you will be able to identify the objects on the ground or even the boundary of the landslide. So that's why the high resolution satellite data sets are used here. Then you have UAV based images and the digital elevation models. So, these are different data sets that is being used in the visual interpretation of the data. Then characteristics identified in the image. So, shape, size, photographic color, tone, mottling, texture, pattern, site topography and settings that can be studied using this visual interpretation. When we go for the automated one, right. So, here some of the traditional pixel based algorithm like threshold segmentation, change detection, supervised and unsupervised classification, these methods are widely used, and here I have also mentioned the references. So, if you are interested in any of these methods, you can refer to their paper for more details. They have nicely represented their methodology. The difficulties in automatic extraction of features arises due to landslide do not have a distinct spectral or spatial signature, right. Why? Because when we talk about a landslide, we are talking about the failure, right, failure of this slope, and this slope can be made up of soil, rocks and the soil of different nature. So, all these different soils and rocks, they have different spectral signature. So, as such landslide do not have any distinct spectral and spatial signature, right. So, whenever you want to identify the landslide, you need to have the high spatial resolution. Then based on the geometry and the shape size, you will be able to identify this is a deformed surface or this is a failed slope. Due to the variety in types of landslide, a large number of possible scenarios are possible. So, the landslide we have already seen, there are very different types of landslide, different types of mass movement, different types of velocity, all of them will have different nature, right. But when we are trying to automatically identify or interpret the remote sensing images for landslide studies, we have to be very cautious because landslide as such, they do not have any distinct spectral or spatial signature, right. So, in such scenario, we have to be very careful, and we should look forward for the parameters that is influencing, right. Then comes the detection of landslide using microwave remote sensing data set. So, the LIDAR, the light detection and ranging data, that is the first choice. Very high resolution DMs can be generated. Detailed spatial information on the surface of the earth. LIDAR can penetrate tree canopy, thus very useful in densely vegetated region, because we are talking about a slope and this slope can have the vegetation, right. So, normal optical remote sensing, that means the visible range or VNIR or SWIR wavelength range, that information will be the reflected energy from this top surface, right. But when we talk about the microwave, microwave has the depth of penetration and that can penetrate the tree canopy. So, microwave remote sensing can provide you the surface information in vegetated conditions. Now comes the DINSAR, differential interferometric synthetic aperture radar. So, it is useful in identification of creeping landslide, because if you remember, creeps are very slow. We need to have a method by which we can identify the millimeter level of creep, right, or the changes. So, that comes with the differential interferometric SAR. So, here what will happen? You will have the continuous measurement at a time interval of the same area, and that will be used to generate the phase information. That phase information will be useful in identifying the velocity or the changes in the area, and that will be in the millimeter level of scale. Permanent scatter interferometry (PINSAR) can identify coherent targets. It allows millimeter level accuracy in estimating the relative target velocity. With this, I will end the part 1 of lecture 30. We will continue this in lecture 30 part 2. Thank you. Thank you very much.